We need to find the half-range Fourier sine series for the function f of x equals 3x in the interval from 0 to pi. In a half-range sine series, we represent the function using only sine terms. This corresponds to an odd extension of the function. The half-range Fourier sine series on 0 to pi is written as the sum from n equals 1 to infinity of bn times sine of nx. The coefficient bn is given by 2 over pi times the integral from 0 to pi of f of x times sine of n x dx. Now substitute f of x equals 3x into the formula. We can take the constant 3 outside. So bn equals 6 over pi times the integral of x sine of nx dx from 0 to pi. To integrate x sine of nx, we use integration by parts. Let u equal x and dv equal sine of nx dx. We choose u equals x and dv equals sine of nx dx. Then do is dx and v is minus 1 over n cosine of nx. Using the integration by parts formula, we get this expression. This simplifies to minus x over n cosine of nx plus 1 over n times the integral of cosine of nx. Integrating cosine gives sine, so we obtain this result. Now we evaluate the definite integral from 0 to pi. At the upper limit x equals pi we get this, and at the lower limit everything becomes 0. Sine of n pi is always 0. So only the first term remains. We know that cosine of n pi equals minus 1 to the power n. Therefore the integral equals pi over n times minus 1 to the power n plus 1. Now substitute the value of the integral back into the formula for bn. The pi cancels, and we obtain bn equals 6 over n times minus 1 to the power n plus 1. Therefore the half-range Fourier sine series is the sum from n equals 1 to infinity of 6 over n times minus 1 to the power n plus 1 times sine of nx. We can also write it neatly by taking the constant 6 outside the summation. This series represents the function 3x on the interval from 0 to pi.